Hello, my Algebra 2 students. Simplifying complex fractions is on the docket for today, which I know when you look at the examples, it looks crazy. It literally means you have a fraction within a fraction. So the steps are already set out here for you just to save us a little bit of time so we can focus our energy over here in the problem. So our goal for this, big goal, is we don't want to have a fraction within a fraction. We're going to try to eliminate the little mini fractions within the big fraction. So the very first step says determine the least common denominator of all the little mini denominators. So when I say mini, I mean the little denominators within the bigger fraction. If it helps, make everything a fraction. So 2 would be a fraction by putting it over 1. 4 would be a fraction by putting it over 1. So when I look at all the little denominators, I have 1, x, x squared, and 1. So my LCD has to include all the factors. So I would need the x from here. And then because this one has x squared, really I need one more x, or it's an x squared itself. So that would be my least common denominator. Second piece, multiply each little fraction by the least common denominator over 1 to eliminate the mini denominators. So that's what we said, we want to get rid of them. All right, I'm going to come through. I'm going to do it in red just so that it doesn't blend in. So I'm going to multiply everything by this guy over 1. So x squared over 1 here, and by x squared over 1 here. Now I'm allowed to do that because of the fact that this over this is just 1. I'm not changing the value. So I need to distribute and multiply it to both parts here, multiply it to both parts there. So what that means, and I'm going to show it slow this first time, is that I have 2 over 1 and then minus 3 over x all over 9 over x squared, and then minus 4 over 1. All right, let me write it out. So times x squared over 1 times x squared over 1 times x squared over 1 times x squared over 1. All right, let's see what happens. So the very first fraction, there's nothing to cancel. There's just ones in the bottom. So I'm going to be left with exactly what I have. So 2 times x squared. All right, then I've got minus. Here goes this next one. All right, here an x and an x can cancel. So this x and one of those x's can cancel. So I'm going to be left with 3 times x. All right, now go to the bottom left. Simplify this little fraction. So x squared and x squared. See you later. We're left with just 9. And then the last piece here, nothing to cancel from the denominator, so we keep the minus 4x squared. All right, that was actually step 3 right there. So simplify, or excuse me, that gets us to step 3. So we multiplied each one to eliminate the little mini denominators. And now when it says simplify the regular fraction, we just are going to factor away. So now it's to the point where we can factor the numerator by taking out a GCF. That'll leave us with 2x minus 3. Factor the denominator with a little difference of perfect squares. So 3 plus 2x and 3 minus 2x. All right. And now this looks like a problem we know how to tackle. So 2x minus 3, 3 minus 2x, those will cancel, but it leaves a negative 1 in its place. So then negative x over 3 plus 2x would be our final answer here. So the goal is really to get it to a problem that we already know how to handle, and then factor and simplify is the last step. All right, let's try it again. When I slide it on up here, this next example, we've got 3 little mini fractions up top, 2 in the bottom. I want you to look at every single denominator and determine what that LCD is. So if I have 12, 6, x, 12, and 3x. So in terms of the numbers, 3, 6, and 12, 12 would be the least common denominator. That's that least common multiple there. In terms of the variables, these each just have a single x, so this just needs a single x with it. That'll cover it. All right, now we're going to multiply everything by 12x over 1. I'm going to write them separate just so that you can see my work. If you think you can squeeze it in to that first spot, go right ahead. otherwise. Let me just make sure that I've got everything, and I do. All right, so let's start multiplying. We're going to multiply this first part by 12x over 1, this guy by 12x over 1, this by 12x over 1. Same thing with everything, whoops, in the bottom. And then our goal, we now have 5 little mini fractions to simplify here. I want every denominator gone. So these 5 are what we now have to clean up. All right, first one, 12s cancel. I'm left with x times x, or x squared. The next one, the 6 and the 12 reduce down to 1 and 2. So I'm just left with a plus 2x. Here the x's go. So we're left with minus 2 times 12, or 24. You know we've done a good job because all the little denominators simplified right out. Bottom step, 12s are gone again. So x times x, or x squared. Here, x's go, and then 3 and 12. Well, 12 is the same as 4 times 3, so there goes the 3's. So I'm left with 4 times 4, or minus 16. At this point, now we're just trying to factor and simplify this. This is a little add multiply guy. This is some difference of squares. So the numerator, let's see, to get 24, we're going plus 6 and minus 4. In the bottom, square root of x squared, square root of 16, 1 plus 1 minus. There goes that common factor, and we are left with x plus 6 over x plus 4. Now, when you hit the answer, you can leave it in the parentheses, or you can drop the parentheses because they're not needed. Either one is acceptable there. All right, we got 2 more on the back. Flip it on over. For the 2 back here, now it's a little bit different because the denominators aren't just single expressions. They're polynomials. So when you look at the denominators here, we have x plus 2. I'm going to put a little parenthesis around that. Here we have x minus 4. Same thing. And then here we have x squared minus 2x minus 8. Before I can pick out my common denominator, or my least common denominator, I need this to be factored so that I can see, like, does it have some of the same factors or not? So when we factor this, let's see, x and x to get 8, we're going 4 and 2. It would need to be minus and then plus, and then look at how perfect that is. Those are the exact same 2 factors that we had here. So when you pick out the common denominator, I have the x plus 2 from here, the x minus 4 from there, and then this whole thing is completely taken care of. Right? Let's do it. You know I'm going to redraw mine just to make sure that you can see it okay. If you're like, nope, I'm good, try it. Get started here. All right, and I'm also going to add those little parentheses to remind myself that it either all goes or none of it goes. All right, so the LCD over 1 means we're going to multiply this guy by x plus 2 times x minus 4 over 1, x plus 2 times x minus 4 over 1, and then lastly, x plus 2 times x minus 4 over 1. All right, you have 3 little mini problems within this. The goal is to get rid of those denominators. All right, top left, x plus 2's go. We are left with 4 times x minus 4. Now you can leave it like that, or it might be easy to just multiply as you bring it on over. So that makes it 4x and then minus 16. All right, second one, the x minus 4's go. So we are left with 2 times x plus 2. Now here's where it can get a little tricky. There's a minus sign in between there. You might want to think about that as a minus 2 getting distributed so that you don't forget about the minus. So that makes it minus 2x and then minus 4 as you distribute that through. All right, into the bottom. Very nicely, that entire denominator cancels. And then all we're left with is 12x minus 120. All right. On the front, we could just factor and be done. Here, we need to clean it up a little first. So 4x minus 2x will give us 2x. Minus 16 minus 4 gives us minus 20. Now we can factor and simplify. So here we have a GCF. We can take out 2 and be left with x minus 10. In the bottom, we have a GCF. We can factor out 12 and be left with x minus 10. All right, x minus 10s are going to go. And then 12 is really the same as 6 times 2. So those 2's are going to go. And now up top, don't forget, when everything cancels, we are left with 1's. In the bottom, we've got that 6. So all of that simplified all the way down to 1 over 6 here. All right, let's save that very last example to do together in class. But what I would like you to do is see if you can figure out what you think the LCD needs to be for example 4. All right, guys, talk to you soon.